The journey of Voyager 2, exploring the cosmos. Absolutely, there is life elsewhere, and almost certainly intelligent life. It has to be. The odds are just overwhelming. These sightings, they go back decades into the past. In the vastness of space, there are places that remain a mystery to us. For millennia, we've looked up at the stars, wondering what lies beyond the reach of our telescopes and imaginations. But one mission, one spacecraft, has gone further than any human-built object ever has before. Voyager 2, launched by NASA in 1977, embarked on a journey that would take it beyond the planets into the deepest reaches of our solar system. But what it saw at the very edge of our solar neighborhood is nothing short of astonishing. Voyager 2 is not just a spacecraft, it is humanity's eyes and ears in the farthest corners of the cosmos. Its mission to explore the outer planets and then continue into interstellar space was revolutionary, but it didn't stop there. After completing its primary mission, Voyager 2 continued to send back data about the farthest reaches of our solar system and, eventually, the unknowns of the interstellar void beyond. Today, we're going to dive deep into what Voyager 2 saw at the edge of the solar system, the surprising discoveries it made, and the unexpected events that have unfolded as it travels farther into space. The journey of Voyager 2. Launched on August 20th, 1977, Voyager 2 was part of NASA's Pioneer program to explore the outer planets. Unlike its twin, Voyager 1, which took a different trajectory, Voyager 2 was on a grander course that would bring it to all four of the gas giants: Jupiter, Saturn, Uranus, and Neptune. This unprecedented path through the outer reaches of our solar system allowed it to gather incredible data about these planets and their moons. By 1989, Voyager 2 had completed its planetary flybys and was sent on an even more ambitious mission to venture into interstellar space. With its trajectory aimed beyond the influence of our sun's gravity, Voyager 2 was about to explore the unknown regions beyond our solar system. In 2018, after more than 40 years of traveling through space, Voyager 2 crossed a major milestone. It left the bubble of particles and magnetic fields created by our sun, entering the interstellar medium. The official crossing occurred on November 5, 2018, making it the second human-made object to leave the solar system after Voyager 1, which crossed this boundary in 2012. But what did Voyager 2 find in this uncharted territory? What is interstellar space? Before we dive into what Voyager 2 saw, it's essential to understand the significance of interstellar space. For decades, we had only theoretical models and observations from afar of what lay beyond the influence of our sun. In simple terms, interstellar space is the region of space that lies between stars, beyond the protective bubble of particles and radiation created by our sun, known as the heliosphere. The heliosphere, a vast region around our sun where solar winds and particles dominate, serves as a protective shield for our solar system. Once you cross that boundary, known as the heliopause, you enter the interstellar medium, the space between stars. The environment here is drastically different from the regions we've known. The density of particles is much lower, and the magnetic fields behave differently. For the first time, Voyager 2 had the opportunity to measure these uncharted conditions firsthand. Voyager 2 crosses the heliopause. On November 5, 2018, Voyager 2 crossed the boundary between the solar system and interstellar space, a place that had never been reached by human-made objects before. This crossing was monumental. Scientists had been waiting for this moment for decades, and when it finally happened, it was a revelation. At this moment, Voyager 2 passed beyond the sun's influence and entered the interstellar medium. But what did that mean for the spacecraft? It meant that Voyager 2 was now in a region where the solar winds, streams of charged particles emitted by the sun, no longer dominated the environment. Instead, it was surrounded by the cosmic winds of interstellar space, which are made up of particles from other stars and galactic matter. For the scientists on Earth, this was the ultimate test. Could their spacecraft withstand the conditions of interstellar space? And more importantly, would it provide data that could help us understand the true nature of this alien environment? The surprising findings: once Voyager 2 entered the interstellar medium, it began transmitting data back to Earth. The first piece of surprising information it revealed was the difference in particle density. In the outermost regions of our solar system, solar wind particles were the most abundant. But once the spacecraft crossed the heliopause, the particles it encountered were much less frequent. These new particles came from beyond our sun, from the galaxy at large, and represented the interstellar winds blowing between stars. In fact, the density of interstellar particles that Voyager 2 encountered was roughly 20 times higher than scientists had anticipated. This gave astronomers new insights into the interstellar medium, showing that our understanding of the space between stars was much more complex than we had realized. Additionally, Voyager 2 encountered a magnetic environment that was very different from the one it had been navigating inside the heliosphere. The magnetic fields in the interstellar medium behaved differently, and this offered scientists valuable new data about the broader galactic environment. The interstellar magnetic field: one of the key findings that Voyager 2 uncovered was the behavior of magnetic fields in interstellar space. Inside our solar system, magnetic fields are influenced by the sun's magnetic field. However, as Voyager 2 moved further out, it began detecting magnetic fields that were not dominated by the sun's influence. This observation is significant because it offers new insights into the structure of the galaxy. By understanding the magnetic fields of interstellar space, scientists can better comprehend the large-scale structure of our galaxy, including how magnetic fields interact between stars, planets, and interstellar dust. Voyager 2's instruments detected that the magnetic field in interstellar space is much more complex than expected. This information is crucial for understanding the fundamental forces at play in the broader galactic environment. Magnetic fields are not just a curiosity, they play an essential role in shaping the interstellar medium and influencing cosmic events such as star formation, cosmic rays, and particle interactions. Cosmic rays. Another major discovery Voyager 2 made was in the study of cosmic rays. These high-energy particles come from supernovae and other powerful cosmic events that occur outside our solar system. As Voyager 2 moved into interstellar space, it began detecting higher levels of cosmic rays than were present within the influence of the sun's solar wind. The increased levels of cosmic rays provide valuable information about the shield the sun creates against these particles in our solar system. The sun's solar wind protects us from the brunt of cosmic radiation. However, once Voyager 2 crossed into the interstellar medium, it was no longer shielded, and the spacecraft encountered a much higher intensity of these particles. This data is critical because cosmic rays can influence everything from climate on Earth to the health of astronauts traveling through space. Understanding their behavior in interstellar space gives us a deeper understanding of the galactic environment and the forces that shape it. Voyager 2's extended mission. Although Voyager 2's primary mission was to explore the outer planets, its true legacy may come from its journey into the unknown. As it continues its path deeper into interstellar space, the spacecraft will keep transmitting data that will provide a wealth of information about this uncharted territory. In 2020, Voyager 2 was still active, transmitting data about the interstellar medium, but as time goes on, its power is expected to diminish. NASA estimates that the spacecraft will continue to send back data for many more years, but eventually it will fall silent. The moment Voyager 2 loses contact will be the end of an era when humanity's reach extended beyond the solar system and into the infinite void of interstellar space. But even when communication with Voyager 2 ends, its discoveries will continue to influence science and space exploration for generations to come. The data it has already sent back has changed the way we think about our place in the universe and the vast, mysterious space that surrounds us. Conclusion. As we look back on the monumental achievements of Voyager 2, it's clear that the spacecraft's journey into interstellar space has been one of the most remarkable missions in the history of space exploration. Its discoveries about the interstellar medium, cosmic rays, magnetic fields, and the nature of space beyond our solar system have opened up entirely new avenues of research and understanding. Voyager 2's legacy is far from over, even as it continues to journey deeper into the cosmos. It will continue to shed light on the mysteries of the universe, giving us a glimpse into the vastness of the galaxy and the secrets it holds. But for now, we can only marvel at the fact that Voyager 2, an object built by human hands, is traveling through the stars, carrying with it the hopes, dreams, and curiosity of all humanity. Its journey is a testament to what we can achieve when we reach for the stars, and it serves as a reminder that there is still so much left to discover about the universe that surrounds us. The role of Voyager 2 in the Voyager program. Voyager 2, while often overshadowed by its more famous sibling Voyager 1, has made an equally significant contribution to our understanding of space. Initially, the spacecraft's mission was to study Jupiter, Saturn, Uranus, and Neptune. Unlike Voyager 1, which took a faster route to reach the outer planets, Voyager 2 took a more extended, looping path that allowed it to perform flybys of all 4 giant planets, creating an invaluable scientific legacy. In 1977, NASA launched Voyager 2 with the primary mission of exploring the outer planets. At the time, our knowledge of these distant planets was minimal, with the farthest planet known being Saturn. The spacecraft's trajectory was specifically designed to take advantage of a rare alignment of the outer planets that occurs once every 176 years, allowing it to visit all 4 giant planets in a single mission. The first major success for Voyager 2 came when it flew by Jupiter in 1979, where it gathered key data about the planet's atmosphere, magnetosphere, and moons, particularly its largest moon, Ganymede. It also revealed new details about Jupiter's famous Great Red Spot, a massive storm system. Voyager 2's findings laid the groundwork for our understanding of the gas giant and set the stage for future missions, including the Juno probe currently orbiting Jupiter. In 1981, Voyager 2 continued its journey, flying by Saturn and providing groundbreaking images and data about the planet's stunning rings and moons. The spacecraft's encounter with Saturn helped scientists refine their models of the planet's rings, including the realization that Saturn's moon Titan had a thick, nitrogen-rich atmosphere, a discovery that later led to the Cassini-Huygens mission. Voyager 2's groundbreaking encounter with Uranus and Neptune. However, the true significance of Voyager 2 came with its flybys of Uranus and Neptune, 2 planets that had never been explored before. The spacecraft's flyby of Uranus in 1986 revealed the planet's unusual tilt. Its axis of rotation is tilted at an extreme angle compared to most other planets, and its faint ring system, which had never been observed in detail before. Voyager 2 also provided the first close-up images of Uranus's moons, such as Miranda, which displayed a geologically diverse surface, suggesting a history of intense geological activity. In 1989, Voyager 2 made history by becoming the first spacecraft to visit Neptune, the most distant of the gas giants. This flyby provided detailed images of Neptune's moon Triton, which revealed active geysers spewing nitrogen ice into space. These discoveries not only challenged our understanding of planetary science, but also laid the groundwork for the discovery of similar activity on moons like Saturn's Enceladus and Jupiter's Europa in later years. Voyager 2's flybys of these distant planets were crucial in shaping our current understanding of the outer solar system. The spacecraft collected invaluable data on their atmospheres, magnetospheres, moons, and rings, data that scientists continue to study today. The decision to extend Voyager 2's mission following the successful planetary encounters, Voyager 2's primary mission officially ended in 1989. However, NASA's mission planners had a different idea for the spacecraft. Instead of bringing the probe back to Earth or letting it drift into the unknown, the decision was made to continue its journey beyond the planets and into interstellar space. The Voyager spacecraft were equipped with instruments that were still capable of transmitting data about the environment around them, even after their planetary missions had concluded. Voyager 2's power supply, which was fueled by a radioisotope thermoelectric generator, RTG, was expected to last far beyond the original mission. Thanks to this, scientists could continue to gather data from the spacecraft long after it had passed the last planet. Voyager 2's extended mission involved exploring the outer edges of the solar system. In 1998, after completing its planetary flybys, Voyager 2 began its long journey toward the edge of the solar system, where it would eventually cross the heliopause and enter interstellar space. This was a path that had never been traversed by any spacecraft before, and it would push the spacecraft's instruments to their limits. The crossing of the heliopause. The heliopause marks the boundary between our solar system and the interstellar medium, the vast expanse of space that exists between the stars. It's the point where the solar wind from our sun, which creates a protective bubble around our solar system, meets the cosmic winds coming from other stars in our galaxy. This is the point at which the sun's influence wanes, and the interstellar environment takes over. On November 5, 2018, Voyager 2 crossed this boundary, becoming the second human-made object to enter interstellar space after Voyager 1 did so in 2012. The crossing was a huge milestone, as it signaled that humanity's reach had extended beyond the confines of the solar system and into the uncharted expanse of interstellar space. The moment of crossing the heliopause was a major event for scientists. The spacecraft began to send back data that showed a stark contrast between the solar wind environment and the interstellar medium. While the solar wind is made up of charged particles ejected from the sun, the interstellar medium is made up of atoms and dust particles from other stars, far less dense but still detectable. For the first time, Voyager 2 was able to measure this new environment directly. The spacecraft's instruments detected an abrupt change in the magnetic field and a drop in solar wind particles. At the same time, the density of the interstellar medium was higher than scientists had expected. This discovery opened up a new chapter in our understanding of the galaxy. Voyager 2's role in expanding our understanding of interstellar space. Voyager 2's observations have been instrumental in shaping our understanding of the interstellar medium. For instance, the spacecraft has detected particles from other stars, such as hydrogen atoms, which have been scattered throughout the galaxy by solar winds and other cosmic phenomena. These particles are the remnants of supernovae and stellar winds from stars that have long since passed away. Through the measurements of these particles, scientists have gained valuable insights into the conditions that exist in interstellar space. They've learned that the interstellar medium is not a complete void, as was once believed. Instead, it's filled with sparse particles, including hydrogen, helium, and heavier elements, albeit at much lower densities than the environment we experience within our solar system. Voyager 2 has also provided detailed measurements of the magnetic field that permeates interstellar space. The spacecraft's instruments revealed that the magnetic fields in this region are far more complex than originally thought. These fields are not only influenced by the sun, but also interact with cosmic structures like supernova remnants and molecular clouds. This has given scientists a deeper understanding of how magnetic fields shape the behavior of the interstellar medium. Perhaps one of the most profound aspects of Voyager 2's mission is its potential to influence the search for alien life. As the spacecraft travels through interstellar space, it is providing new data about the conditions necessary for life to exist in other star systems. Understanding the makeup of the interstellar medium, the cosmic rays, and the magnetic fields is critical for assessing the habitability of exoplanets in other star systems. Voyager 2's continued legacy. As Voyager 2 continues its journey deeper into interstellar space, it is expected to keep transmitting data back to Earth for many more years. However, as with any spacecraft, its power will eventually run out. NASA estimates that the spacecraft's instruments will begin to lose power in the mid-2020s, at which point Voyager 2 will no longer be able to send back data. Even then, its legacy will continue. The data that Voyager 2 has collected has already made an indelible mark on our understanding of the outer reaches of the solar system and the broader galaxy. The spacecraft's journey into interstellar space has fundamentally altered our understanding of space, providing crucial insights into the nature of the galactic environment, the interstellar medium, and cosmic phenomena that influence the entire galaxy. In the years to come, Voyager 2's data will continue to be analyzed, yielding new discoveries and insights. The mission has already surpassed all expectations, far outliving its original design life and providing a wealth of information that will shape our understanding of space for generations to come.